Question 10 here starts out giving me 3 different integrals that I already know the answers to, then asking me to manipulate one of those integrals. If you remember back to the practice problems on a question like this, they would use different parts of the integral for different things. So here, since I'm only really giving you one part of the question, you might not use all the information they give you. Specifically here in question 10, I'm asking in my sample example, what's the integral from 2 to 7 of 1/5 x cubed dx? For that problem, I don't need this integral and I don't need this integral. All I need is this 596.25. Essentially, that's the answer to this integral if I pull this 1/5 constant out front. So what I really need to do is 1/5 times 596.25. If I put that into my calculator and I take 596.25 times 1/5, that gives me an answer of 119.25. For number 11, it asks me to find the area of a region. When I'm finding an area, I'm really integrating. So in this case, what I'm integrating is my y function, or f of x, 3 plus the 5th root of x dx. But because I'm going from x equals 0 to x equals 32, those end up being limits on my integral so that it's not an indefinite integral. So here I'm going to put 0 to 32. When this gets integrated, 3 becomes 3x. X to the 1/5, I add 5 over 5 to it. That becomes 6/5. So I get plus x to the 6/5 divided by 6/5. This is all being evaluated from 0 to 32. That means it's really 3x plus 5, the 5th root of x to the 6th over 6, evaluated from 0 to 32. So first thing I'm going to do is put in 32. When I put in 32, I'm going to get 3 times 32, or 96, plus 5 times the 5th root of 32 to the 6th. 5th root of 32 is going to give me the value 2. After I take that 2 and take it to the 6th power, it gets me back to 64. That's why this becomes 5 times 64 over 6. When I plug 0 into here, I get 0. When I plug 0 into here, I get 0. So it's really minus 0. If I do this math in my calculator and I take 96 plus 5 parentheses 64 divided by 6, that gets me to a total of 149.33 repeating. So just be careful, however many decimals it asks you to go to, put that many 3's after the decimal place. Problem 12 is an indefinite integral where we need to use u substitution. In this case, u equals 1 plus 4x, du equals 4 dx. We already have 4 dx, so I don't need to change the equation any. I can just rewrite it as the integral of u to the 6th du. Now when I integrate, it becomes u to the 7th over 7 plus c. And my last step is to replace that u with what I know u to be equal to. So that becomes 1 plus 4x to the power of 7 over 7 plus c. Same idea for number 13. I'm going to need to do u substitution because it's a reverse chain rule. The difference is, instead of already having my dx available here like I did, du equaled 4 dx, here I'm going to have to manipulate the equation to make the du match. So I'm going to start by setting up what my u equals. It's the thing under the root, 20 minus x squared. If I take the derivative of the left side, I get du. Derivative of the right, derivative of 20 goes away, it's just 0. Derivative of negative x squared is negative 2x dx. I currently have x dx, so I want to multiply the inside of the equation by negative 2. In order to make sure that I mathematically hadn't changed the problem, I then have to multiply the outside by negative 1/2, because negative 1/2 times negative 2 gives me positive 1, which means I haven't really multiplied by anything. So this integral is going to become negative 1/2 the integral of u to the negative 1/2 du. Now I can integrate. Negative 1/2 becomes positive 1/2. So I still have the constant out front, negative 1/2. But the power on my u I added 2 over 2 to. So it becomes u to the positive 1/2 divided by 1/2 plus c. This really can be simplified. Negative 1/2 times 2 over 1. All that goes away and just leaves me with a negative sign. Under the square root, I have my original u, which is 20 minus x squared plus c. So again, the key thing to understand here is dividing by 2 over 1. Or I'm sorry, by 1 over 2 is like multiplying by 2 over 1. That 2 and that 2 go away. I just have 1 over 1 with a negative. That's why all the fractions reduce to that negative sign.